Right, today we're going to do notes on 5.3. So 5.3, we're going to be graphing radical functions, all of our favorite things put together. There's square roots, cubed roots, and graphs. Fun stuff. So on this page, we have our graph of our parent functions. First parent function is the square root graph. So one thing to note is that you can never have a negative under the square root. So x can never be negative. So our graph starts at 0 and goes in the positive direction. Our domain is x is greater than or equal to 0, because we can never have a negative number for x, which means we'll never have a negative number for y either. So our range is y is greater than or equal to 0 also. And anytime we see a square root, our graph is always going to have this shape. So our square root graphs always look like this. Our cubed root graphs are a little bit different because we can have a cube root, a negative cube root. So it is the same shape in the positive direction, but we can also put it in the negative direction too. So the cubed root can be negative, so we have this little squiggly line as our graph. And since it can have negative numbers, our domain and range is always all real numbers. So for the cubed root, our domain and range are always all real numbers. All right, let's get started. So graph each function, identify the domain and range of each function. So to graph, we're going to start with a box. We're going to plot our points in it. So we're going to have numbers for x, get values for y, and then we're going to have points x comma y. So we have the square root. What's the first number we should plug in here to get a point? What do you think? 0. So let's plug in 0. When we plug in 0, we have the square root of 1/4 times 0, which is just the square root of 0. And what's the square root of 0? 0. So our first point is going to be 0, 0. Let's go to our graph, plot our point. What should we plug in next? Let's plug in 1. So we have the square root of 1/4 times 1, which is just the square root of 1/4. What's the square root of 1/4? In your calculator.
Can you say just a little bit?
0.5. So when we plug in 1, we get 0.5. So let's go to our graph, go to the right one, go up 0.5. What should we plug in next? 4. Awesome. 4 is a great number to plug in because we're multiplying it by 1/4, and that would give us a nice whole number. So let's plug in 4. So we have the square root of 1/4 times 4, which would be the square root of 1. What's the square root of 1? 1. So if we plug in 4, we get 1. So we go to our graph, we go to the right 4, and up 1. Once we have about 3 points, we can go ahead and draw our shape. So our graph looks like this. Kind of has that curve and then flattens out a little bit. All right, let's identify our domain and range. So domain is our x values. We did not plug any negatives in here for a reason, because we can't have a negative under the square root. So what do you think our domain is? What's the smallest x value we can plug in here? 0. So our domain goes from 0 and then what's the largest x value we can plug in? What? Infinity. We can plug in as big of a number as we want. Our graph goes forever in the right direction, so our x values continue to grow and grow and grow. So our domain goes from 0 to infinity. So to find out what the domain and range is by looking at the graph, domain is our x values, so always start with the smallest and go bigger, so start with the left side. And where does our graph start? It starts at 0, and then it keeps going forever in the right direction, so our domain keeps going to infinity. And now let's look at our range. So our range is our y values. We start at the bottom, keep going up until we hit the graph. What's our smallest y value on our graph here? 0. And then what do you think our largest y value can be? Infinity. Awesome. So our graph, as we plug in bigger numbers for x, we get bigger numbers for y. So our graph keeps going forever in the y direction also. All right, next one. So graph each function, identify the domain and range. So first thing we need is our little box. We're going to plug in values for x, get values for y. We have points x, comma, y. So what should we plug in for x? Notice we have a cubed root graph here. What can we plug in for x? 0. So we have -3 times the cubed root of 0. What's cubed root of 0? 0. And what's -3 times 0? 0. So we plug in 0 and got 0. So we go to our graph, put our point at 0, 0. What can we plug in next? What number could we put under a cubed root to give us like a nice whole number?
A 3.
What would the cubed root of 3 be? What are factors of 3? 3 and 1. Do we have any groups of 3 that we're circling? No. We could do 8, but what's a number smaller than 8 that's a perfect cubed root? 1. We can do the cubed root of 1. Did you say that, Alex?
No.
Oh, okay. So let's plug in 1. So we have -3 times the cubed root of 1. What's cubed root of 1? 1. And what's -3 times 1? negative 3. So we plugged in 1 and got negative 3. So let's go to our graph. We're going to the right one and down 3. What else can we plug in? Negative 1. So since it's the cubed root, we can have negative numbers. So we want to plug in some negatives too. So let's plug in negative 1. So negative 3 times the cubed root of negative 1. What's the cubed root of negative 1? Negative 1. So what's negative 1 times negative 3? 3. So when we plug in negative 1, we get 3. So let's go to our graph. Go to the left one, up 3. Let's plug in one more point on each side. Casey, what was a good one that you said? 8. 8 is great because that rhymes, because it gives us 2, 2, and 2. We're circling groups of 3, so we would circle all 2 of our 3s, all 3 of our 2s. And what would our answer be for the cubed root of 8? 2. So the cubed root of great works, the cubed root, oh my gosh, words are hard today. The cubed root of 8 works perfectly because it gives us a nice whole number. So next we want to plug in 8. We have negative 3 times the cubed root of 8. We said the cubed root of 8 was 2. And what's 2 times negative 3? Negative 6. So when we plug in 8, we get negative 6. So we go to our graph. We're going to go to the right 8 and down negative 6. So it's going to be a little bit off of our graph down here. And then what's one more number we can plug in on the negative side? Negative 8. Awesome. Usually whatever we plug in on the positive side, the same thing on the negative end ends up being a whole number also, so that works. So we have negative 3 times the cubed root, negative 8. What's the cubed root of negative 8? Negative 2. And what's negative 2 times negative 3? 6. So we have negative 8, 6. So we're going to go to the left 8 and up 6. So it's important that our graph has that same shape as our parent graph. So it has to have like that squiggly line shape. So that's why I plugged in more numbers here so we can kind of see that shape happening. This is not great, but you guys see the shape. So it has this squiggly line going on. So next, let's identify our domain and range. So what is our domain? Awesome. Our domain is all real numbers. We can write all real numbers, or we can do this little all real numbers shape, an R with like 2 bars. And then what is our range? All real numbers. The graph for the cubed root will always have the domain and range of all real numbers. So the square root graphs, you kind of have to think about what your domain and range is. For the cubed root, it's always going to be all real numbers for both.
Range.
Anytime it's a cubed root, your domain and range will be all real numbers. Here we have some transformations. So if it gives us a function, we don't have to plug in numbers every single time to graph it. We can just take our parent function and apply the transformation that's happening to it. So if we have a negative, or if we have a number being added or subtracted on the inside of our radical, whether it's square root or cubed root, doesn't matter, same thing happens to both. We have a horizontal translation, which means it shifts it left or right. So just note that if it is a minus on the inside, if you're subtracting a number, you go to the right. If you're adding a number, you go to the left. So on the inside, it's kind of the opposite of what you think. If you subtract, you go to the right. If you add, you go to the left. If you are adding or subtracting on the outside of your radical, that is a shift up or down. So this, it's the same as what you would think. If you're adding, you go up. If you're subtracting, you go down. And then we also have reflections. So if you're multiplying the inside by a negative, so if that x on the inside is being multiplied by the negative, you're reflecting on the y-axis. If the outside is being multiplied by a negative, you're reflecting on the x-axis. These are our reflections when you're multiplying by a negative. And then we're going to skip the stretch and shrinks. So we did this in chapter 1. This box looks super duper similar to the ones that we did in chapter 1. We've done transformations before. This is not new. We know you guys know how to do horizontal and vertical stretch and shrinks and identify them, so we're skipping them for now, for this section. Merry Christmas. Transformations. So we always start with the parent function, and then we just take it and shift it. So let's plug in numbers for our parent function so we see what's going on here. So we have the square root of x. What should we plug in first for the square root of x? Zero. We don't want to plug in any negative numbers because we don't want any negatives under a square root. So what is the square root of 0? 0. So we plug in 0 for x and get 0 for y. Our first point is at 0, 0. What can we plug in next? 1. So what's the square root of 1? 1. So we plug in 1, get 1. Our next point's at 1, comma 1. And then what's another number we can plug in that would give us a nice whole number to work with? 4. Awesome. 4 is the next number that's a perfect square root that we would get a whole number. So what's the square root of 4? 2. So we have our next point as 4, comma 2. So we're going to go to the right 4, up 2. Once we have our 3 points, we can draw our little curve. So this is our parent function. This is the graph of f of x, the square root of x. Now we take our parent function and shift it the way the g of x tells us. So what does this minus 3 tell us? Where do we go with that minus 3? Minus 3 on the inside. Awesome. We're going to the right 3. And then what about this minus 4 on, or plus 4 on the outside? Up 4. So we take all of our points in our parent function, we're going to shift it to the right 3 and shift it up 4. So we take 0, 0. We go to the right 3, up 4. Put our point there. We take 1, 1. Go to the right 3, up 4. Next point goes there. And then we take 4, 2. Go to the right 3 and up 4. And then we just draw our curve. Our graph keeps the same shape as it did before. All we do is move it. So we just take it. You can highlight it on Notability, drag it to its new position. It keeps the same exact shape, but just a different position. We just shift it a little bit. So identifying the transformations or describing the transformations that this question asks us to do, it's just right 3 and up 4, and then our graph is the yellow line. So in the homework, you have a few problems where it says describe the transformation, then graph each function. You don't have to graph the parent function every time. if you just graph the parent function once, you can just like copy and paste it and just shift it on the graph that it needs to go on. So you don't have to graph the parent every single time. Your parent function is always, always, always going to have these 3 points. These are the 3 main points for your parent function of the square root of x graph. So once you start with these 3 points, all you do is shift it the way that your g of x tells you to go. Any questions on this one? So our graph, oops.
Yeah.
Thank you. All right, so next we have g of x is equal to the square root of x plus 1. Identify the domain and range of the function. So we have to graph and identify our domain and range. So we have a square root graph. That means our 3 points for our parent function are the same as they were before, 0, 0, 1, 1, and 4, 2. This is our parent. So we take our parent and shift it the way that g of x tells us to shift. So we have this plus 1 on the inside. Which way does this tell us we go? Left 1. So since it's a plus on the inside, we go left 1. So we take all of our points from our parent function and just move them to the left 1. So 0, 0 gets shifted to the left, 1, 1 gets shifted to the left, and 4, 2 gets shifted to the left. And then we just draw our curve. Keeps the same shape, just gets shifted to the left. Yes?
At some point, would they merge together and become one line?
As the numbers get bigger, yes, because if you, let's say like we plugged in 100 here. The square root of 100 would be 10. The square root of 101 would be like 10.01 something. They get like super close to each other. So at some point, as the numbers get really big, the graphs get closer together, like they did here. Like our graphs will get closer. So at this point, they're one space away. This point, they're one space away. But like actually they're a little less, but whatever. As like the points get closer, the graphs get closer together. As the points get bigger, the graphs get closer. So at some point, they start to level out. So let's identify our domain and range. So what's our domain here for our g of x graph? What is our smallest x value? Where does our graph start? What x value does our graph start at? -1. So our smallest x value here is -1. And then what's our largest x value that our graph could have? Infinity. Our graph goes forever in the right direction. So our largest x value is infinity. So just remember, domain is x values, range is y values. So what is our smallest y value we have? If we start down here, where does our graph start? What y value does our graph start at? 0. And then what's our largest y value? Infinity. So our range goes from 0 to infinity. Because we can plug in 1,000,000 for x and get whatever the square root of 1,000,000 is for y, but it would still be a super big number, so our range goes to infinity. Any questions on this one? So when you're dealing with square roots, your domain and range can change depending on how you're shifting it. But when you're dealing with the cubed root, your domain and range will always be what?
All real numbers.
All real numbers. Thank you. All right, last problem. So here, we haven't done the parent function of the cubed root yet. So let's plug in some points to find what our parent function is here, and then we can shift it the way our g of x tells us. So what should we plug in for the cubed root of x? Let's plug in 0. So we have the cubed root of 0. What's the cube root of 0? 0. So our first point is 0, 0. What else can we plug in? 1. What's the cubed root of 1? 1. So our next point's 1, 1. Go to right 1, up 1. What else can we plug in? -1. So cubed root, we can plug in negatives. So what's the cubed root of -1? -1. So -1 is our third point. Now we really only need 3 points here, but if you connect these points, it kind of looks like a line. We know our graph of the cubed root of x is not a line, it's a curve. So just keep in mind that your graph has a curve. You can plug in more points if you want to, but all you need is 3 because we're just going to shift them anyways. Just know that your graph has this curve. It's not a straight line, it's got a curve to it. Alright, so now let's look at g of x and let's apply our transformations. So what does this negative on the outside tell us to do? Flip it. So a reflection on which axis? Awesome. X's stay on the outside. So x axis. And then what does this -2 on the outside tell us we're doing? Down 2. So we have 2 transformations, a reflection on the x-axis, and we're going down 2. So our x-axis is here. And we just need to flip all of our points on it. So 1, 1 is now going to be 1, -1 down here. 0, 0 stays the same. And then -1, -1 becomes -1, +1. So when we flip our graph, it looks like this. So it's the same thing, just flipped on the x-axis. But we also need to shift it down 2. So we take our 3 points, which now our graph is the blue one, and just shift it down 2. So down 2, and down 2. And then we keep that same shape. So our graph of g of x is the green one. The blue one is just like an intermediate shape, a middle one that we had to, you don't have to do, but that we can do to show us what the reflection is. Sometimes it helps to split up the reflection and your shift, so just take it one step at a time. So this is our graph, the green one. It doesn't tell us that we have to, but what's our domain and range here? What's our domain?
All real numbers.
And what's our range?
All real numbers.
All real numbers. Awesome. Any questions on the notes from today?